Before diving into any data analysis or machine learning project, it's crucial to understand why cleaning and preparing your data is so important. Raw data often contains errors, inconsistencies, and missing values that can lead to misleading results if not addressed. By investing time in cleaning your data, you ensure that your analysis is based on accurate and reliable information. This process helps you avoid common pitfalls and sets a solid foundation for all subsequent steps. In this video, we'll walk through the essential techniques and best practices for cleaning and preparing data so you can make the most of your datasets. Raw data is the starting point for any data project. It's collected from various sources and often comes in an unstructured or semi-structured format. This means it may include typos, duplicate entries, missing values, or irrelevant information. Recognizing the nature of your raw data is the first step toward effective cleaning. By examining your dataset closely, you can identify common issues and plan your cleaning strategy accordingly. Remember, the quality of your final analysis depends heavily on how well you understand and handle your raw data. As you familiarized yourself with your raw data, the next step is to identify specific issues that need attention. Common problems include missing values, outliers, inconsistent formatting, and duplicate records. By systematically scanning your dataset, you can spot these issues early and decide on the best approach to address each one. This proactive step saves time in the long run and ensures your data is ready for meaningful analysis. Let's explore how to detect these common data problems. Missing values are a frequent challenge in data cleaning. They can occur for various reasons, such as data entry errors or incomplete data collection. There are several strategies to handle missing values, including removing rows, filling in values with averages or medians, or using more advanced imputation techniques. The best approach depends on the nature of your data and the importance of the missing information. Carefully consider the impact of each method before making changes, as improper handling can introduce bias or distort your analysis. Duplicate records can skew your analysis and lead to inaccurate results. It's important to identify and remove duplicates early in the data cleaning process. Most data tools offer functions to detect and eliminate duplicate rows based on specific columns or the entire dataset. Always double-check before removing duplicates to ensure you're not discarding valuable information. By keeping your data unique and consistent, you set the stage for more reliable insight. Consistent data formatting is another common issue, especially when data comes from multiple sources. For example, dates might be recorded in different formats or categorical values may have various spellings. Standardizing these formats is essential for accurate analysis. Use data cleaning tools or scripts to convert all entries to consistent format. This step not only simplifies analysis, but also prevents errors during data processing and visualization. Outliers are data points that differ significantly from others in your dataset. They can result from errors or represent rare but important events. It's crucial to identify outliers and decide whether to remove, correct, or keep them based on your analysis goals. Visual tools like box plots can help spot outliers quickly. Always document your decisions regarding outliers to maintain transparency in your data cleaning process. Ensuring that each column in your dataset has the correct data type is vital for accurate analysis. For example, dates should be stored as date objects, and numerical values should not be mixed with text. Data type mismatches can cause errors during calculations or visualizations. Review your dataset and convert columns to the appropriate types as needed. This step helps prevent issues later in your workflow and ensures your data is ready for processing. Not all data collected is useful for your analysis. Irrelevant columns or rows can clutter your dataset and slow down processing. Take time to review your data and remove any information that doesn't contribute to your goals. This streamlining step makes your dataset more manageable and focused, allowing you to concentrate on the variables that truly matter for your analysis. Categorical data often contains inconsistencies, such as different spellings or abbreviations for the same category. Standardizing these values is essential for accurate grouping and analysis. Use data cleaning tools to unify categories, ensuring that each unique value is represented consistently. This step is especially important when merging datasets from multiple sources, as it prevents misclassification and improves the quality of your results. Many machine learning algorithms require numerical input, so categorical variables must be converted into numbers. This process is called encoding. Common methods include one-hot encoding and label encoding. Choosing the right encoding method depends on the nature of your data and the algorithm you plan to use. Proper encoding ensures your models can interpret categorical information correctly, leading to better performance. Numerical data can vary widely in scale, which may affect the performance of certain algorithms. Normalization is the process of adjusting values to a common scale, such as between 0 and 1. This step is especially important for distance-based algorithms like k-nearest neighbors. By normalizing your data, you ensure that each feature contributes equally to the analysis, preventing larger values from dominating the results. Feature scaling is another technique to adjust the range of numerical variables. Unlike normalization, which typically scales values between 0 and 1, standardization transforms data to have a mean of 0 and a standard deviation of 1. This is particularly useful for algorithms that assume data is normally distributed. Applying the right scaling method helps improve model accuracy and convergence speed. For building models, it's important to split your data into training and testing sets. This allows you to evaluate model performance on unseen data and avoid overfitting. Common splits include 70-30 or 80-20 ratios. Make sure the split is random to ensure a representative sample in each set. Proper data splitting is a key step in preparing your data for machine learning tasks. Data transformation involves converting data into a suitable format or structure for analysis. This can include operations like aggregating, pivoting, or reshaping data tables. Transformations help reveal patterns, simplify complex datasets, and prepare data for modeling. Understanding basic transformation techniques is essential for effective data preparation and analysis. Aggregation is the process of summarizing data by grouping and calculating statistics like sums, averages, or counts. This is useful for understanding trends and patterns at a higher level. For example, you might aggregate sales data by month or region to identify key drivers. Aggregation simplifies large datasets and makes it easier to draw meaningful insights. Pivoting is a technique that allows you to reorganize data tables for easier analysis. By turning rows into columns or vice versa, you can highlight relationships and compare different variables more effectively. Pivot tables are especially useful for summarizing large datasets and creating reports. Mastering this skill will help you analyze data from multiple perspectives. Often, you'll need to combine data from multiple sources to get a complete picture. Merging datasets involves joining tables based on common columns, such as IDs or dates. It's important to ensure that the join keys are clean and consistent to avoid mismatches. Proper merging expands your dataset and enriches your analysis with additional information. Filtering allows you to focus on specific subsets of your data that are relevant to your analysis. You can filter rows based on conditions, such as date ranges, categories, or numerical thresholds. This step helps you eliminate noise and concentrate on the most important information. Effective filtering streamlines your workflow and improves the quality of your insights. Text data requires special attention during cleaning and preparation. Common tasks include removing punctuation, converting text to lowercase, and eliminating stop words. You may also need to perform stemming or lemmatization to reduce words to their root forms. Properly cleaned text data is essential for natural language processing and text analysis tasks. Noise in data refers to irrelevant or random information that can obscure patterns and reduce analysis accuracy. Detecting noise involves identifying out-of-place values, errors, or artifacts that don't belong. Removing noise improves the clarity and reliability of your dataset, making it easier to uncover meaningful insights. Always review your data carefully to spot and eliminate noise. Consistency is key to reliable data analysis. This means that similar values are recorded in the same way throughout your dataset. Inconsistent data can lead to incorrect groupings and flawed results. Regularly check your data for consistency, especially after merging or transforming datasets. Consistent data ensures your analysis is accurate and trustworthy. Keeping a record of your data cleaning steps is essential for reproducibility and transparency. Document each change you make, including the reasons and methods used. This practice helps you track your progress, troubleshoot issues, and communicate your process to others. Well-documented cleaning steps also make it easier to update or repeat your analysis in the future. Annual data cleaning can be time-consuming, especially for large datasets. Automation tools and scripts can speed up the process and reduce human error. Popular tools include Python libraries like Pandas and specialized data cleaning software. Automating repetitive tasks allows you to focus on more complex issues and ensures consistency across your projects. After cleaning your data, it's important to validate the results. This means checking for any remaining errors, inconsistencies, or missing values. Validation ensures that your cleaning steps were effective and that your data is ready for analysis. Use summary statistics and visualizations to confirm data quality before moving forward. Once your data is clean and validated, save it in a secure and accessible format. Common formats include CSV, Excel, or database tables. Make sure to use clear file names and version control to keep track of changes. Saving your clean data ensures you can easily access and reuse it for future analysis or modeling. Data loss can happen unexpectedly, so it's important to back up your clean datasets regularly. Use cloud storage, external drives, or backup servers to keep copies of your data safe. Regular backups protect your work and ensure you can recover quickly in case of hardware failure or accidental deletion. Version control isn't just for code, it's also useful for data. By keeping track of different versions of your clean datasets, you can easily revert to previous states if needed. Tools like Git or specialized data versioning systems help manage changes and collaborate with others. Version control adds an extra layer of security and organization to your data workflow. In cleaning and preparing data, always consider privacy and security. Remove or anonymize sensitive information such as personal identifiers to protect individuals' privacy. Follow relevant regulations and best practices for data handling. Ensuring privacy builds trust and helps you comply with legal requirements. Ethical considerations are vital in data cleaning. Avoid manipulating data in ways that could mislead or misrepresent the truth. Be transparent about your cleaning methods and document any changes made. Ethical data practices ensure your analysis is fair, accurate, and trustworthy. Clean and well-structured data is essential for effective visualization. Remove unnecessary columns, ensure consistent formatting, and aggregate data as needed. Proper preparation makes it easier to create clear and informative charts or graphs, helping you communicate your findings more effectively. Modeling requires data to be in a specific format with all variables properly encoded and scaled. Double-check that your dataset meets the requirements of your chosen algorithm. Address any remaining issues such as missing values or outliers before training your model. Well-prepared data leads to better model performance and more reliable predictions. Data leakage occurs when information from outside the training dataset is used to create the model, leading to overly optimistic results. Carefully review your data preparation steps to ensure that no information from the test set is included in the training set. Preventing data leakage is essential for building robust and generalizable models. Feature engineering involves creating new variables or modifying existing ones to improve model performance. This can include combining features, extracting date parts, or creating interaction terms. Thoughtful feature engineering can reveal hidden patterns and boost the predictive power of your models. Always test the impact of new features on your results. Imbalanced data occurs when certain categories are underrepresented in your dataset. This can bias your analysis or model predictions. Techniques like oversampling, undersampling, or using specialized algorithms can help address imbalance. Always evaluate the impact of these methods to ensure your results remain valid and unbiased. Time series data has unique challenges such as missing timestamps, irregular intervals, or seasonality effects. Cleaning time series data involves filling gaps, ensuring consistent intervals, and handling outliers. Proper preparation allows you to analyze trends, forecast future values, and build reliable time-based models. Data enrichment involves adding external information to your dataset to provide more context or improve analysis. This can include demographic data, geographic information, or industry benchmarks. Enrichment helps you gain deeper insights and make more informed decisions. Always ensure that added data is accurate and relevant to your goals. Data profiling tools help you understand the structure, quality, and content of your dataset. These tools generate summary statistics, detect anomalies, and highlight potential issues. Profiling is a valuable first step in the cleaning process, guiding your efforts and helping you prioritize tasks. Familiarize yourself with popular profiling tools to streamline your workflow. Data cleaning is often a team effort, especially in large projects. Collaborate with colleagues to share knowledge, divide tasks, and review each other's work. Use shared documentation and version control to coordinate efforts and maintain consistency. Effective collaboration leads to higher quality data and more efficient workflows. Data quality is not a one-time task. Set up regular checks and monitoring systems to catch new issues as they arise. Automated alerts and dashboards can help you stay on top of data quality over time. Continuous monitoring ensures your data remains clean and reliable for ongoing analysis and decision-making. Even experienced analysts can make mistakes during data cleaning. Common pitfalls include overcleaning, losing important information, or introducing new errors. Stay vigilant and double-check your work at each step. Learning from past mistakes and following best practices will help you avoid these common traps. Using open data standards makes it easier to share and integrate datasets across different systems. Standards ensure consistency in formatting, nomming, and structure. Adopting these practices improves collaboration and reduces errors when working with external partners or tools. Data cleaning tools and techniques are constantly evolving. Stay current by following industry news, attending workshops, and experimenting with new tools. Keeping your skills up to date ensures you can handle new challenges and make the most of your data. There are many resources available to help you master data cleaning and preparation. Online courses, tutorials, books, and community forums offer valuable guidance and support. Take advantage of these resources to deepen your knowledge and stay ahead in your data journey. Cleaning and preparing data is a foundational step in any data project. By following best practices, using the right tools, and staying vigilant, you can ensure your data is accurate, reliable, and ready for analysis. Remember, high-quality data leads to better insights and more successful projects. Keep refining your skills and embrace continuous improvement as you tackle new data challenges.